Quality control is critical to our process. It lets us have exceptionally good beam currents at the accelerator because we make sure that there are no contaminants that have made it through the process. We do quality checking to ensure that the chemistry we have done up to this point has been done accurately and correctly. We want to ensure that every cathode that goes to the AMS will perform optimally. That means that the sample needs to be both high yield, retaining its aluminum beryllium that it started with, and free of other impurities. Accordingly, at the end of every batch, we check every beryllium and every aluminum sample. After finishing cation column chromatography, the samples are evaporated overnight. The first thing we do before moving forward is to redissolve each in 1% nitric acid. We add this dilutant using a pipette, mixing the sample well in its Teflon beaker, and then transferring it to a new acid-washed centrifuge tube. At the end of this process, we have 12 tubes of beryllium and 12 tubes of aluminum, one for each isotope for each sample. The equipment setup for quality checking is rather involved. We start with a hot plate on which the samples have dried off overnight. We then have a rack of new pipette tips. We have to change pipette tips for each and every sample to prevent crosstalk or contamination. We have a variable beryllium pipetter. We have a container for used tips. We have a rack of samples. We have a Vortexer. We have tubes for aliquots that will be taken out of each of our samples. We have a dilution pipetter. It's variable and holds 5 ml because we're going to add dilutant liquid to each of our samples. We have that dilution solution. It's a weak sulfuric acid solution, which we will pour into a beaker for this dilution solution, and we'll remove some of it using the variable pipette. From each sample, we use micropipettes to withdraw a very small amount of liquid, 200 microliters from the beryllium samples and 50 microliters from the aluminum samples. It's very important to use a new pipette tip for every sample to avoid any cross-contamination. Each of these small aliquots is then diluted with 1% sulfuric acid in preparation for ICP analysis. We test the yield and purity of each sample using ICP OES. All further sample processing pauses until we have these results, usually in a couple hours. The ICP data help us verify two things. First, that virtually all of the beryllium and aluminum have made it through the extraction process intact. That's usually more than 95% yield. Second, that the beryllium and aluminum are free of other impurities, which might inhibit their performance on the AMS. Only once samples are verified to be both high yield and pure do we continue with the remainder of the process, which we detail in the next video. At this point, once we know we have our samples, we discard the TI fractions that we saved during the cation column chromatography method. Let's recap. We do quality control sampling at the end of our process. This ensures that the beryllium and aluminum fractions are pure and have high yield, so we get the best AMS measurements. We take a small aliquot of each sample and dilute that aliquot volumetrically. We then make ICP analyses of the aliquot to determine yield and purity. Impure samples are reprocessed, and the other samples, as you'll see in the next video, are precipitated to aluminum hydroxide and beryllium hydroxide gels.